So we are going to do an overview of acids and bases and look more into pH, the pH scale, and how we actually calculate the pH. But here we go with acids. Acids are an aqueous solution that increase the concentration of the hydrogen ion, H+. They have a pH value of 0 to 6. They taste sour, so if you think of acids and you think of lemons and vinegar, those both contain different acids and they taste sour. In the chemical formula, acids have an H, a hydrogen, as their cation, and acids react with metal to form hydrogen gas. That's what will be produced. Whereas bases, they're an aqueous solution that increase the concentration of the hydroxide ion, the OH negative. Their pH value is from 8 to 14. When we are writing out their chemical formula, they usually have the hydroxide polyatomic ion, the OH negative. They taste bitter and they feel slippery. Bases feel slippery. So if you think of cleaning products are usually bases. So our laundry detergent or soaps, those are both bases and they feel slippery. Let's talk about the pH scale. We know it goes from 0 to 14. But pH, to get more technical, is calculated from the concentration of the hydrogen ion. So if we look right here, we have our equation for pH. It's the negative log base 10 of the concentration of hydrogen ions. That's how we calculate it. So with pH, we also have this other value known as pOH. And it's the same basic equation, but it uses the concentration of the hydroxide ion. So it's a negative log base 10 of the hydroxide ion. So if you look, this small p means to take the negative log base 10 of whatever comes after it. So here with pH, it's of the concentration of hydrogen ions. Here with OH, it's of the concentration of hydroxide ions. And these two values, pH and pOH, are related to each other by pH plus pOH equals 14. So we're now going to use these equations and these values with some calculations. So here, we have all those equations, and we're going to work on calculating pH and pOH. So the first question, it says, determine the pH of a 0.00467 molar, that's molarity, hydrochloric acid solution. So I'm just going to make this bigger. Okay. So we want the pH and we have this concentration. So we are going to use this equation. So if I take the negative log, making sure my log is capital, and you see if I just click, I want it to be sub 10. That, and then I do my concentration with square brackets. And here's my concentration. So I have the negative log sub base 10 of my concentration. Shift enter. Sorry. So I don't want it as, with Mathematica, I don't want this 10 here to be a subscript. We just want to write it. And here I have my pH value. I need 3 significant digits. So my pH will be 2.33. And hydrochloric acid is an acid. So this 2.33 for pH makes sense to us because that's where acids lie, between 0 and 6. So I can use the hydrogen concentration to figure out the pH value. But I can also do the reverse. I can use the pH value to figure out the concentration of hydrogen ions. So number 2 is saying, determine the hydrogen concentration in a solution that has a pH of 3.78. So here, if I take 10 and raise it to the negative pH value, that will give me my hydrogen ion concentration. So if I do 10, and I do Control 6 with that caret, I'll get the superscript, and I do negative 3.78, Shift Enter, I get the hydrogen ion concentration. We need 3 significant digits. And there I have my answer. So that was pH. But now number 3 is saying, oops, I don't need, oh, I'm missing question 4. So number 4 is using the pOH. Okay, sorry, let's go back. So number 3 is saying, determine the pOH of a 0.0034 molar solution. So pOH is the negative log of the OH hydroxide value concentration. So if I do negative log 10, oops, what just popped up? I do not want that. Okay. So for negative log 10 square bracket of 0.0034, Shift Enter. This is my pOH. So the pOH of my sodium hydroxide would be 2.5 because I need 2 significant digits. Then we go to 4 and it says, using the pOH value from number 3, calculate the pH value of the sodium hydroxide. So I'm going to use this equation. And if I'm just going to copy it here. So I know that my pOH is 2.5. So if I do 14 minus 2.5, my pH value is 11.5. And that makes sense for a basic solution. So we were just using these equations to determine the pH and pOH value of different substances. I would like you to do numbers 5 through 8 on your own.